All right, and MCT4C, day 56 and day 2 of our solving polynomial equations escapades. Um, Today we're going to pull a couple of tricks out of our hat from last unit and from back in maybe grade 10 or grade 11, and we'll see how that works in just a second. Let's get at it. The goal for the 3-minute review is to use graphs to find the roots of a polynomial function. The graph shown is that. So this is the graph of this function. Starts low, ends high. It's got 3 roots and 2 turning points, so I could convince you that that's that function. It says use the graph to estimate the solutions to that polynomial function. Well, notice this whole thing is y equals that. That's this graph. We want to look for the spot where y equals 0. Well, y equals 0 is, there's the when y equals 0 is right along here. Any spot where it crosses the x-axis, the x-intercept. So we're looking for x-intercepts. And x-intercepts and solutions to equations x-intercept of functions, solutions to equations, and we'll also call them roots. We also think of roots as the solution to an equation or x-intercepts of functions. These are all, we all use these kind of interchangeably, even though they're more accurate to be listed in these contexts. X-intercepts is a function, solution is an equation, and we usually think of roots of equations as well, although we think of them as x-intercepts as well. So notice all we have to do is sort of read off of these the graph what the x-intercepts appear to be. And the x-intercept looks like it's going to be at a half, looks like it's going to be at maybe almost 2. I put a big X there, which messed me up a little bit, but X is maybe about, say, 1.8 maybe, and X equals -2. And those are all estimates. And there we go. That equation is solved using the graph. All I would have to do is graph the function and look for the x-intercepts, right? So that's the technique there. Graph the function, look for x-intercepts. Gotta get the phone. I'll be back in a second. I was a stupid telemarketer on the phone. I hate when they phone and interrupt videos. Well, that gave you a chance to do this, right? And if it didn't, you should go and do those questions. There are questions that are just like this, very, very quick questions. Check them in with Bob, back of the book. Check the answers in the back of the book. There's solutions in the back of the book, so you can do that, okay? So do that, and then we'll get back into the lesson. I'm going on with the lesson right now. Expectations today: to solve polynomial equations using various strategies, including technology. So we already saw or started thinking about how we would use a graph to solve some equations, and now we're going to do this one. This one looks like it can be factored, but when I think about it, numbers that multiply to get -10 and add to get -4, there just ain't any numbers. It doesn't work. This doesn't factor. But if you remember, there was a technique, and you learned about this in grade 11 probably, and maybe in grade 10, depending on what class you took in grade 10. The quadratic formula says that if you've got this equation, the solutions are x equals -b plus or minus the square root of b squared minus 4ac all over 2a, right? And there's 2 solutions there because it's negative b plus this and negative b minus this. And so we're going to practice using the quadratic formula here. And there's all sorts of goofy songs. If you remind me in class tomorrow or next class to play some, I'll play you some goofy songs that help you remember this. Goofy songs. Write that down there so I'll remember to play a couple. But we can use that to solve these equations that don't factor. Just have a look. There's the quadratic equation, and you've got it memorized, of course. Who doesn't? How would you get by normal life not knowing the quadratic equation? All right, that better be somebody important to interrupt the quadratic equation. I'm going to get the phone. All right, A is 1, B minus 4, and C equals negative 10. And we substitute into the quadratic formula, and negative 4, that's going to be a plus 4. You wouldn't even normally write that as a negative 4. I just write that as plus 4, except for it's the first one we've seen in a little while. So watch your signs there. That's negative 4 all squared minus 4ac all over 2a, like this. And I'm going to simplify this. I'm going to do as much of this as I can in my head here. That's a 4. 4 plus or minus the square root of 16, and minus 4 times minus 10 is positive 40. That's 56 there over 2. So I've got x equals 4 plus the square root of 56 over 2, and 4 minus the square root of 56 over 2, right? So probably your textbook might have the answer just like that. That's certainly possible. I would be okay with a decimal answer, so notice that we need brackets along the top here, otherwise we'd mess this up. Bracket 4 plus the square root of 56, and bracket divided by 2. I get 5.7-ish. Approximate answer. Notice what's nice about the graphing calculator, your scientific calculator as well, is usually you can go up into the last thing, and I just went second enter to get to the last entry, and then I can just go back and change that to a minus. It's pretty slick. Saves a little time. Negative 1.7-ish. Is that what that was? Is that what I saw? Yeah. Good. And there's my two solutions, both approximate solutions, and that's the quadratic equation. Let's get on to the next example. Is this I was going to say, is it the last example, but it just ain't. And notice we should try and factor this, because the quadratic formula is actually quite a few steps. It's way faster to factor. So I should try this, but I'll tell you it doesn't work, okay? So the quadratic formula is, and if you're good, you can probably substitute into this straight off without having to rewrite it again. So negative b, see what it there? Negative 1 plus or minus the square root of b squared minus 4ac all over 2a. And then there are my solutions. Well, I've got to do some work here. I've got g equals 1 plus or minus that, and that is going to be 61 over 6. My two solutions. The positive one is 1 plus the square root of 61 over 6, and g is about 1.47 about, and g is about equal to negative 1.14-ish, around there. A couple of decimal places, and there are the answers. Now some people, by the way, now that you remember the quadratic formula, we've seen it for the first time this year, some people might prefer that to factoring. I know the quadratic formula works in this case, but some people have trouble factoring hard trinomials. So if you have trouble factoring hard trinomials, well, you know, you could skip that and go straight to the formula, and there it is. All right, C, part C. Notice cubic. No common factor, no grouping, so I'm going to have to use the factor theorem. Quadratic formula is just for quadratics, and with the cubic, I'm going to call that f at x, and I'm going to try and find something that divides into it. F at 2 works, I think. 2 cubed minus 5 times 2 squared plus 2 plus 10, and that's equal to 0. So therefore, x minus 2 is a factor. And then long division. You know, we've done a few of these now, haven't we? You're getting to be masters of the long division. And whoops, minus 3 works there. What was that? That's plus x comes down, and minus 3x works there. Minus 3x squared plus 6x. Subtract, watch your... And remember, it's got to work, right? This has got to work out. So if it doesn't, we goofed. And it does. Right? And so what do I have then? I have this thing. This equation then becomes x minus 2 and x squared minus 3x minus 5. Well, we saw some of these last class where, you know, this gives us one of our solutions, x equals 2, and this thing factored. Well, this doesn't factor. This part doesn't factor. So we are stuck, right? Well, not really, because I could use the quadratic formula on this part. For this part, I'm going to use the quad formula. What do I got? I got A equals 1, B equals minus 3, C equals minus 5, and here we go. X equals 3 plus or minus the square root of negative 3 squared minus 4A, and C is minus 5, and this is getting to be a mess, but that's okay. 2 times 1, 3 plus or minus the square root of 9 plus 20. Doing that in my head. X equals 3 plus the square root of 29 over 2, and x equals 3 minus the square root of 29 over 2. And notice your book, the textbook, might have the solutions just written like this. There are the solutions, those three. Or it might write them in decimal form, and I'm going to write them in decimal form. We've got 2 as one of our solutions. This one, when I pound it into a calculator, you should get around 4.19, and this one is, what is that? That's negative 1.69, about. That's that one, and that's that one. 3 solutions. And that kind of makes sense, because if I thought of the quadratic function, starts low, ends high, it probably has 3 zeros. And in fact, I know that it does, and I could actually list them now, because I've got x equals 2, x equals 4.1 is one of the roots, and x equals negative 1.69. Negative 1.69 is one of the roots. So actually, I know all the x-intercepts of that function. Good. So far, so good. We got one more. And I know the video is getting long here, but I'm just going to pound through this last example, and it's going to be all good. This feels like it's another of the same one. No common factors, no grouping, so I'm going to call that f at x, but there's a problem. Of course there's a problem. If I try f at 1, f at minus 1, f at 7, f at minus 7, none equal 0. No factors. So no factor theorem. Factor theorem fails. So what do? We quit, right? No, no, we don't quit. What we're going to do is we're going to turn to technology. When the factor theorem fails, turn to the TI-83, right? And so what we're going to do, we're going to graph y equals that function, y equals this function. So grab the old, warm up the old graphing calculator. There she is. Isn't she lovely? And then y equals, and I got a whole bunch of old crud in here that I'm going to have to clear out. And then I'm going to type in that equation. When I do that, then I'm going to use, these are old skills now for us because we did all that stuff on polynomial functions last chapter. And I'm going to use what I know about graphs to solve polynomial functions. I'm going to start with Zoom 6 is the standard, and hopefully I'll be able to see all the roots. Huh. How many roots? It looks like there's just one, and it's right there. Notice that it does the little snake shape above the x-axis, so there is only one root. It starts low, ends high, one root, and I'm going to find it using the calc menu. Right? I'm going to find a 0. Got to go to the left of the root and to the right of the root, and then in between. There we go. I'm going to copy this, okay? You should draw the sketch. I'm going to copy. Come on, you. Copy. Thank you. Paste that in there. Grab this, put her down there. So I'm going to say from the graph, '83 0 function. The the solution is x equals negative 1.09 about, and that's the only solution. Okay. All right. So the homework today, I think that's it. Yep, that's it. The homework today is a mixture of the quadratic formula, a mixture of doing some using graphs, and using the TI-83 like we just did here to solve them. So have fun with that. That's day 2 of solving polynomial equations. Stay classy, MCT4C.